All right, so good evening. I hope you're all doing well. Today, we are going to take a step further in machine learning model development. Today, we are looking at a special case of a model that we can develop or that we can build. And today, we are looking at the convolutional neural network. I believe for those of you who are very inquisitive and curious about some of the things that we have been doing, you probably might have seen the convolutional neural network around in some books or maybe in some personal readings that you might have done. So we are going to see them. Now, one of the things I keep on saying is the previous knowledge that we have about model development, classification, and things of that kind is nothing different from what we are going to do today, except that the model that we are going to build is going to have a different architecture. Okay. It's almost like putting up a building. If it is not a story building, the architectural design and maybe some of the materials you put in there will be different from if you are building a skyscraper or maybe a two-story building or anything of that sort. So yes, we are going to use neural networks, but then the architecture is going to change a little bit. And we are going to learn a few things about this convolutional neural network. So this is just a short note. Let me share these are all materials you'll find on my GitHub repo, which we always make available for students to also have a look at. So these are basically some notes. Okay, so we want to learn a few things about what this convolutional neural network is. So this is a neural network. It's a network architecture for deep learning. And in deep learning, all that we want to do is want to learn directly from the data. Okay, we want to learn some inherent patterns within the data structure. Now, in some context, the word convolutional is a simple or simply means we are multiplying or is a multiplication of frequency domain. So there's a lot of multiplication that will be done over here. Yeah. Now, for the objectives of whatever thing we are going to do today, we want to build an artificial neural network using the convolutional neural network architecture. We want to use that as a classifier to classify images. And in this particular instance, we are going to do a gender classification. So we are going to have some images of some males and then images of females. We build a model and then we let the model learn features about males and then features about female, and then we're able to make some predictions. And then we're also going to do what we usually do after building every model is to do some comparison analysis, okay? So this is just what we are going to do. But before we can even get into we building these models, we need to be very conversant with the kind of data that we are working with. Now, over the past few days or weeks that we started this, most of the data that we worked with are some numerical inputs. So we've seen um, the very first data we spoke about was the iris data sets. There were just some dimensional length. Okay, so petal length in centimeters, petal width in centimeters, and sepal length and sepal width. So those were the things that we dealt with. Now, this time around, we are having images. So the manner in which we treat image, we do the pre-processing, and anything around images are also going to be a little bit different. Now, in order to understand images very well, let me also share this with you in order to understand this one. These are all from the GitHub repository. These are some old things that we did. Okay, so I'll share Control C and then I'll paste it in the chat. So we would want to look at a few things, okay? And one of the things we would want to look at is how are images formed? How does the computer understand images? So if you're able to figure that one out, then we can know how we can also present that kind of image to the computer to do the pre-processing. Because one of the interesting things we know about computers is the fact that they are digital devices, okay? And they operate in the realms of binary. So they only understand zeros and ones. So how on earth is the computer going to see an image and then see a zero or one dimension of it? Okay. So that's what we are going to do today. And it is probably something you already know. You are just drawing your mind to it and then try and connect the dots. Some of these things you learned back in secondary school. So we are going to look at how images are formed. And the first point we have over here is images are formed when white light reflects off an object onto a film. So the concept of the pinhole camera and all those things we did back in primary and then in secondary school, those are the things that we know as far as images are concerned. Now, it is important to know that the very source of light, okay, nature as we have it on this earth is the sun. And before the sun gets to us, when you go into space, the kind of radiation you meet over there is different from when we are on Earth. Okay. So we know that within the electromagnetic spectrum, there are different wavelengths. Okay. So for instance, you have the radio waves, you have the microwave, infrared, and then this is the range we enjoy most, which is the visible light range. Okay. There's ultraviolet, and then X-ray, and then gamma rays. Some of these waves are quite harmful to human beings. But then this is okay because this is what we enjoy on Earth. Now, the visibility range, okay, which we get that concept of white light. In retrospect, is a white light range made up of the 7 rainbow colors. So we also remember that experiment we did back in the days where we used a glass prism, we throw in a light to disperse the various composition of colors we have in that white light. So we know that in that visible range, we have a combination of 7 colors, and these are the rainbow colors. So we have red, orange, yellow, green, blue, indigo, and violet. All right. Now, in digital representation, images are basically a grid made up of a combination of colors. So what you see over here, which is this image, what the computer sees is the computer basically puts a grid, okay, put some lines, some box lines on the image. And then it analyzes each grid one by one to actually get some numerical representation of it. And we are going to see with some example, we are going to generate our own image and see how some of these things work. So the fourth point I have over here is each grid is a pixel. And you know that from the elementary basis when we are doing ICT, you know that, oh, we say pixel is picture element, okay? So it is almost like the atom of a picture, okay? The smallest building block of a picture is what we refer to as a pixel. And each pixel is definitely going to be made up of a color. So over here, we are saying that, look, these are the grids. And if I'm to zoom in, I'm getting maybe a particular color, okay? And we should also know that these colors are going to be derived from what we know from the primary colors. So the primary colors, um, depending on the kind of book you read, you may have different colors before referred to as the primary colors. But regardless of whatever color you are talking about, the primary colors are the fundamental colors, okay? And out of the primary colors, we can mix based on the combination that we have to get the secondary colors and then tertiary colors and then any other color that you can ever think of. You can do a combination of these primary colors together. So we are saying that even though this color looks like orange, okay, and by default, orange is not a primary color, but we can mix 2 or 3 primary colors to get an orange color, and that's what we are trying to say. So the point is, in computer vision, the computer uses RGB, okay, color ratio for its primary color combination, and the RGB The R stands for red, the G stands for green, and then the blue stands for green. So these are the primary colors the computer uses. And if the computer wants to get maybe a secondary color like violet, okay, I remember back in the days, one of the simplest examples our teacher used in class, in order for us to get violet, was to use the red pen and then the blue pen. Okay, the red is a primary color, the blue is a primary color. Mix the two, and then we go violet. So those are the combinations the computer will do to get other colors and stuff like that. And for those of you who have probably worked in had the opportunity to work in a space where you worked with the photocopier machines, okay, the colored printers, you see that the color toners, you don't put all the colors in there, just the primary colors, and then the computer will work its magic out, do a combination, and then get the secondary colors for the printing to be done. So each color or each pixel, okay, is a combination of the intensity of the RGB ratio ranging, okay? And this one ranges from 0 to 255. So 0 is the least, and then 255 is the max. Now, when I say the intensity, what I mean is, if for instance, okay, with the examples we have stated out over here, so kindly pay attention. We know that the RGB, so the first value is going to represent red, the second value is going to represent green, and then the third value is going to represent blue. Okay. So over here, when the highest intensity in terms of the color is 255. So that means red is 255, and then green is 0 and blue is 0. That means you have more red than any of the other colors. So that means the final output of the color that I'm going to have is going to be red. In the case of green, then that means the red component, which is the first number represented over here, is going to be 0. And then the green component is going to be 255, which is the max. And then blue is going to be 0 by. So this is going to be like a very pure green. And then in the case of blue, the red part is going to be 0. The green part is going to be 0. And then the blue part is going to be of high intensity, which is going to be 255. So now this is where we get the various other colors, okay? The secondary and the tertiary colors. So if I want to get a different color like yellow, then I'm thinking of mixing red and then green. So this is going to be a very deep yellow. And then for black, I don't want any white lights coming in, okay? So the intensity is going to be 0, 0, 0. So that means everything is going to be black. Now, a perfect white is what we have over here, 255, 255, 255. So the intensity is all at the max, and then we get this. Now, let me show you one way you can also experiment with this, okay? And this is an application we have on our laptops. So you open up what I have over here as paint, okay? So with this paint, you see that, look, I can select maybe this color, black, and maybe pick a brush and then maybe start doing scribbling some colors over here. But what I want to show you is what I just explained, okay? So when I click on the color editor or edit color, I want to be very specific of the color that I select out over here. And you can see that the color is going to show up over here. And then you see RGB. Okay, so the red, green, and then the blue combinations are over here. Currently, it is 0, 0, 0, and that's why I'm getting the black. Okay. What about if I change this to 255? You are going to see that this is also going to change. So when I do 255, you see that now the color over here has now changed to red. Okay. And if I click on OK and then start scribbling some whatever thing over here, I see that, okay, this is a color red. All right. In that same way, if I was to come here and then take this back to 0 and then the green part is 255, then you could see that I have a very pure green over here. And then whatever thing I do over here is going to be that green. Okay. Now, finally, let's do one for the blue. So in terms of the blue, let's put this to 0 as well. And then the blue side of things, let's do 255 over here. So you see that we have the color blue. And then whatever thing we do over here is going to be blue. All right. Now, let's do maybe a secondary color. So like I was trying to explain, let's use red. So let's do 255 over here. And then let me take this. Yes, so this is the red is 255, and then the blue color, okay, the blue pen. And then we are getting a violet over here. So when I do this, and then we have this violet color showing up over here. Now, it isn't the case that everything is going to be 255, okay? Zero is the minimum, and then 255 is the maximum. So anything within that range. So basically, what I'm trying to do over here is in this case, okay, if it is zero for red and zero for green, and then blue is 255, all I'm trying to say is this is more or less like the purest version of blue you can ever think of, okay? All right. So this is one way of looking at it. For those of you in maybe the computer engineering class, or those who have gone beyond maybe some of the things you are taught in the classroom to do some personal studies yourself. If you have been doing maybe some web development in particular, and also in other things that you can ever think of, and then you try doing anything CSS, okay? So let me call this main.css. CSS is basically cascading style sheets, and that's what we use to style um, HTML documents, okay? So this is just something which is not related, but I just want you to understand that, look, these are things you probably might have used in the past. So let me just bring in something over here, and then, yep. And let me bring my CSS file over here. So let me link my CSS, and then this one is going to be main.css. All right. So typically when you are developing a website, this is how you go about it. You'll be writing your code, and then you'll be styling and doing other things. Okay. So that concept is also here, because if I want to maybe change the color of a text to maybe some color, okay. And let me just say I have an H1 tag over here. This has got nothing to do with machine learning. So just um, if as much as possible, pretend as if you didn't see this. But I just want to show you that this RGB thing that's probably maybe you are hearing for the first time, it's nothing new, okay? So let's say I have machine learning showing up over here. I'll save this, and then I'll open it up in Live Server. So this is going to open up in my browser, and let's see what happens over here. Okay. All right, so that's what we see over here. Okay, so by default, everything you type over here is going to be black. Okay, now I can come inside of this, go into my CSS. Okay, because I've already linked it, and then I can target maybe the H1 tag. Okay, and then I can give a color over here, and I can do red. Okay, so when I do red, now the color of the text is going to change to red, as you can currently see over here. All right. So we can, in CSS, we can use the normal colors, okay? And when I say the normal colors, I'm referring to their normal names. So I can use red, I can use green, okay, and then the color is going to change to green. Okay, I can use any other color name that I want. But in addition to this, I can also hover around this, and then you see that I have the RGB showing up over here. So over here, once again, red, green, blue. Okay, so the intensity of red is 0 over here. The intensity of the green is 128. Okay, this is not even to the max. Okay, and then the intensity of blue is also 0 over here. So I can actually click on this, and then make the changes myself. Um, yes. So I can do the 255 over here, and then this is going to be like the proper green that I want. Okay. All right. But one of the interesting things you should note is, look, with all this that we are doing, okay, I want you to pay attention to the color blue. If I try putting in maybe an invalid input, let's say 400, Okay, I mean, the system has been designed that look, there's a max, so it doesn't even allow you to put anything beyond the maximum value over here. So the point I'm trying to make is this is how images are formed. Now let's take this a step further to actually analyze something over here. Okay, and I want you to pay attention. So let's assume we are creating our own image. Okay, and in that our own image, the first color I want to deal with is the color red. So in terms of RGB combination, I have 255 and then 00 for the green and the blue. So what I want is, I want the brush over here. I want to do some painting. So I'm having the color red painted over here. If this was my picture, no matter how you look at it in terms of my face or whatever, there's going to be, colors, colors thrown onto some film, okay? That's basically what you see. So this is the red, okay? And let me also paint the edge over here red. We should have probably done Ghana colors for red, gold, green, or something like that, but then no problem. This is okay. So I have red over here. Now let's do another color for the middle part. So let's do 0 and then let's do green. So 255. I want a very green over here. So let me do this. And then we have this showing up over here. So I have green. And then let's have another color, the ones that we know very well, blue. So let me put 0 over here and then let me put 255 for blue. So over here for the color blue, I have 255 over here. And then let's do black. Okay, so for black, the intensity, everything has to be 0. Okay, so 000, that means we don't have any elements of red, any element of any other color. So we are getting a very dark color. So let's put black over here. So at least we have some colors that we can identify the numbers. Okay, that's the goal of whatever thing I want us to see over here. So I have these colors over here. All right. Now what I'm going to do is I'm going to save this image, and then let me call this let's say test underscore image over here. All right. So I've saved this, and then I believe this is going to be saved over here. So I have this image, the one we have just created out over here. Okay. All right. Now, in the next few things that we are going to do, we are going to analyze this image to see that, look, if this goes into a computer, would a computer actually see this red as 255? Okay. That's exactly what you want to establish over here. So now let's go back to our learning. So we are saying that this is what usually happens. Okay. So at the end of the day, the computer does not see Kojo or Ama, but then the computer sees numbers. And these numbers are derived from the colors. And how the numbers comes about from the colors is the fact that every color is made up of a combination of some colors. If it is a primary color, then it is a combination of its color itself and then a low intensity of the other colors. If it is a secondary color, it is a combination of whatever combination that you have, okay, for any other color you can ever think of. All right. So what I'm going to do is I'm going to create on my desktop, I'm going to create a new folder and then let's call this CNN, okay? So in the CNN folder, I want to bring this particular image in there so that we can experiment with it and see whatever thing is happening. So I'm going to open up my Jupyter Notebook environment, and then we are going to start right away. So I'm starting my Jupyter Notebook server in that particular folder I just created.